It's not unusual to hear programmers claim that it's impossible to write unit tests for some code. There are a lot of reasons why this might happen. I'm going to address one and demonstrate a solution. This isn't the only reason that code may seem to be untestable, and it's not the only solution to the particular scenario that I'll be presenting. Here, we have a function that does something time-consuming. For the purpose of this discussion, exactly what it does isn't important, and I've omitted it entirely to make things clearer. What is important is that it records its start and end times. If we look at the first test example, we have something that I see quite often. The developer has chosen to completely ignore validating the start and end values. This is a common issue in my experience, and if we go back to the code, we can see that there's actually a bug here that the test fails to detect. Did you spot the bug? It's the kind of thing that can easily happen after code has been refactored a few times. Without a test, it can easily slip by. This second example test is a common improvement on the first. At least we're now testing that start and end are set to something, but we still aren't detecting the bug. To fully test this, we're first going to modify the original code. I feel like it's important to stress that modifying code to make it easier to test is a good thing. In the long run, the code will be more maintainable as a result. What I've done is extract the actual work into a helper function that is called by the function that is intended to be used by consumers. The helper function takes an additional parameter, a function that returns a time value. The original function passes the time.now function as that parameter, which results in behavior identical to the original code. However, we can now write a test that fully validates the result by writing our own function to return a time. In order to test it fully, we create a function that mimics the behavior of time.now but produces predictable results. In this example, I'm just using an array of values and return each value in turn. We can now ensure that the entirety of the return structure is correct, and this test detects the bug. This technique will work in other scenarios where a result would normally be unpredictable, such as the generation of a UUID. The astute among you will notice that I've just created a mock. The reason the script to this video is organized this way is to show that mocks solve problems. It's surprising to me how many times I've seen testing suites that make extensive use of mocks and yet still have code like this because some parts seem impossible to test. To use mocks correctly, you have to understand the problems they're designed to solve. Also, I could have used one of many available mocking libraries. However, I wanted to demonstrate exactly what a mock is doing and how easy they are to implement without forcing an understanding of any particular library. This video is about understanding application of this technique, not about learning any specific implementation. I hope this video is helpful the next time you come across code that feels impossible to test.